On the basis of the rules that we have done, we will now consider the image formation by convex lens for various positions of the object. While locating the position, nature and size of image formed, the object will be considered to be situated on the left side of the lens so that incident rays travel from left to right. Remember, only thin lenses are considered whose aperture is very small as compared to its radii of curvature. Before we draw ray diagrams, to observe and learn about the position, nature, and size of the image formed by a convex lens, just observe the changes in the size of image as the object is shifted toward the lens in the animation which will come forth. Now here you can see a convex lens. An object is moved towards the lens. The object size is shown in the box below. Here is the object size, and you will find the changes in the image that is taking place in this box. So observe carefully how the object is moving towards the lens and the image formed is changing. Here, see, this object is moving slowly and slowly, the size is increasing, and then it becomes, the object reaches infinity, and when it comes very close by, then a virtual image is being formed. Ray diagrams of image formed by convex lens. First, when object is at infinity. Now here you can observe that light rays are falling. Now first ray, these rays are coming from some far off object which is at infinity. Let's say a far off tree or a far off building, something like that. And we have taken one ray which is passing through the optical center, which will go undeviated. Another ray is taken parallel to the first ray, and after refraction it is going and converging at this point, which is the focus. So the image formed will have these characteristics. Now see, the image is formed at the second focus of the lens. The image will be real because it is formed by actual convergence of the rays. It is inverted, you can see upside down, and it is highly diminished because the object is at infinity, and it can also be even point sized. Second, when object is beyond 2f. Now here this object is beyond 2f, so one ray is taken parallel to principal axis, and you know after refraction what will happen to it? It will pass through the focus. You can see it is passing through the focus. Second ray is taken passing through the optical center, and you all know when it passes through the optical center it will go undeviated. Now these two refracted rays are meeting at this point. This light had originated from this point A. So we'll see the image of point A at this place, which is given as A dash over here. And this point image will be formed on principal axis itself. So we get this image formed over here. So we can observe that the image is formed between, can you see, it is formed between F2 and 2F2. It is real, right? Because actual intersection of the rays it is being formed due to, it is inverted and the size is diminished. Now you can see over here a simulation in which three rays are taken to show. See, first ray, if you observe, is parallel to the principal axis, and after refraction is passing through the focus. Second ray is passing through the focus and becomes parallel to principal axis. Third ray passes through the optical center, and you get the image after between F and 2F. Third, when object is at 2f1. Now, here you can see that there is an object which is placed where at 2f1. One ray is being taken parallel to principal axis. After refraction, it is going to pass through the focus. Another ray is taken through the optical center, and after refraction, it will move undeviated. So these two refracted rays are converging at the point A dash, right? And you can see that they are converging just at below 2f2. That means the image is formed. Object also was at 2f1 and the image is also formed as 2f, right? So we can say the image is formed at 2f. It is real, inverted and same size. When object is between f1 and 2f1. Now in this diagram, you can see that this is F, this is 2F and the object is between F and 2F. Again, we have taken one ray parallel to principal axis. After refraction, it passes through the focus. Another ray is taken to be passing through the optical center and after refraction, it moves undeviated. So these two refracted rays are converging at this point A dash, and you will observe that this is beyond 2f. So the image form will be, position of the image is beyond 2f. It is real, inverted and enlarged. When the object is f1, that means the object is at the focus. So here, this is the focus. The object is placed at focus. A ray of light parallel to principal axis after refraction passes through the focus. Another ray which is passing through the optical center goes undeviated. So you can see that these two rays are parallel to each other. And parallel rays are supposed to be meeting at infinity. So we say the image formed is at infinity. And these rays will keep on moving down and down. So you know the image will be highly enlarged. So the characteristics of the image become, the position is at infinity. The image will be formed at infinity. It will be real and inverted and it will be highly magnified, or you can say it will be highly enlarged. Finally, when the object is between the focus and optical center. Now here you can observe this object. It is between the optical center and the focus. One ray is taken parallel to principal axis. After refraction, it passes through the focus. Another ray is passing through the optical center. You will observe that these two rays are diverging away from each other, isn't it? Since they are diverging away from each other, they will keep on moving away from each other and will never meet on this side. But if you extend these rays backward, they will be appearing to come from this point A dash. Remember, I'm using the word they will be appearing to come from point A dash. So the image is A dash B dash, which is formed where on the same side as the object. So since the rays are appearing to come from here, obviously, which kind of image it is? It is a virtual image. So finally, the characteristics of the image is on the same side of the lens as object. The image is virtual, erect, and it is enlarged, or you can say it is magnified. So these are the image formations of the object by keeping it at various positions in front of the lens.